Hello dear students, in this video I'll continue with the 5th unit Inferential Statistics. Here we will see what is t-test for two independent groups. I'll also solve the questions from 1 to 6 of exercise 21.2, chapter 21, Applied Mathematics by D Sharma. First we will see what is this t-test for two independent groups. This t-test for two independent groups, it compares the mean of two different groups and checks whether there is any significant difference between those two means. Usually, this t-test compares the two groups, namely the experimental group and the control group. Now, this experimental group, it is nothing but it is the group on which the study is done or the research is made. To see whether there is any significant impact of the research or the study on this experimental group, the researcher usually will have a group what is called the control group. The control group is the group on which no experiment is conducted or no research is done, or they are free. They are just another group where we want to check whether there is any significant difference between this experimental group and the control group, or whether the study which is conducted, it is having some impact or not. So the use of this t-test for two independent groups is that it helps us to see whether a statistically significant difference exists between the two means. It means the two sample t-test, it compares two group means. Now let us take an example. It is expected that boys will have higher mathematics scores than girls. So this is just an example. So if we want to write the hypothesis for this, then we have the null hypothesis H0. Null hypothesis H0, it states that there is no significant difference between the mathematics scores of boys and girls. It means mu1 equal to mu2. So that is the mean mathematics scores of boys and girls are the same. So that is null hypothesis. And then we have the alternate hypothesis. So the alternate hypothesis H1, it states that there is significant difference between the mean mathematics scores of boys and girls. That is mu1 not equal to mu2. So this is how we have to write the hypothesis. Now we will see how the test statistic T should be written. Now coming to the test statistic for t-test for two independent groups. In this t-test for two independent groups, we have got two different cases. The first case is the variance of the groups are assumed to be equal. That is sigma 1 square equal to sigma 2 square. And the second case is the variances are assumed to be unequal. That is sigma 1 square not equal to sigma 2 square. So here we will discuss about when the variances are assumed to be equal. So when the variances are assumed to be equal, when two independent samples are assumed to be drawn from population with identical population variances, that is sigma 1 square equal to sigma 2 square, then the test statistic T, it is computed as T equal to x1 bar minus x2 bar upon SP into root of 1 by n1 plus 1 by n2. Here n1 and n2 are the sample size of group 1 and group 2. Sample sizes of group 1 and 2 respectively. And then x1 bar is the sample mean of the first group. So it is 1 by n1 summation I equal to 1 to n x1I. x2 bar is the sample mean of the second group. So it is 1 by n2 summation j equal to 1 to m x2j. And then the pooled variance, this SP, it is called the pooled variance. It is given by Sp is equal to root of n1 s1 square plus n2 s2 square upon n1 plus n2 minus 2, where s1 square and s2 square are the sample variances. So this is how the test statistic T is calculated for two independent groups and the variances are assumed to be equal. So we have to use this formula. Again we can simplify this, x1 bar minus x2 bar upon sp into root of n1 n2 upon n1 plus n2. When we take LCM and when we simplify, we get this expression for the test statistic T. So S1 is the standard deviation of first sample, S2 is the standard deviation of second sample, ST is the pooled standard deviation, a combined estimate of the overall standard deviation. So using all these values, we can find T. The first question, the mean life of a sample of 10 electric bulbs was found to be 1456 hours with standard deviation of 423 hours. A second sample of 17 bulbs chosen from a different batch showed a mean life of 1280 hours with standard deviation of 398 hours. Is there a significant difference between the means of two batches? So here we have two different batches of electric bulbs. The first batch of 10 electric bulbs have a mean life of 1456 hours and standard deviation of 423 hours. Another batch of 17 bulbs, it has a mean life of 1280 hours and standard deviation of 398 hours. Now we have to check whether there is any significant difference between the means of the two batches using two sample t-test. So here the level of significance is not given, so we can assume level of significance is 5%. Assuming alpha is equal to 0.05. So first step is we have to write the null hypothesis and the alternate hypothesis. The null hypothesis H0, mean life of both the batches are the same. And then the alternate hypothesis, mean life of the two batches are different. Now the test statistic is given by T is equal to x1 bar minus x2 bar upon sp into root of 1 by n1 plus 1 by n2, or it is equal to x1 bar minus x2 bar upon sp into root of n1 n2 upon n1 plus n2. So we have here, let us write here what are all given. N1 is 10 electric bulbs, then x1 bar is 1456 hours, and then this sample standard deviation S1 is 423. Then N2 is 17, it is given. Then X2 bar is 1280 hours and the standard deviation is 398 hours. Here the degrees of freedom is, it is given by N1 plus N2 minus 2. So when we have two independent sample t-test, then and when the sample variances are equal, then the degrees of freedom it is given by N1 plus N2 minus 2. So we have to check the table value for 5% level of significance and N1 plus N2 minus 2 degrees of freedom. N1 plus N2 minus 2. So this is equal to root of 10 into 423 square plus 17 into 398 square upon 10 plus 17 minus 2. So this is equal to root of numerator. When we simplify, we get 17,89,290 plus 26,92,868 upon 25. So this is equal to 1 by 5 into root of 44,82,158. So this is equal to 2117.1 upon 5. This is equal to 423.4. Now we can find T. So T is equal to 1456 x1 bar minus x2 bar. x1 bar is 1456 minus x2 bar is 1280 minus 1280 upon the sample variance is 423.4. This is 423.4 into root of n1 into n2 upon n1 plus n2. So 10 into 17 upon 10 plus 17. So this is equal to 176 upon 423.4 into root of 170 upon 27. So this, when we simplify, we get this as upon 423.4 into 2.5. So this is approximately equal to 1.04. So we get the calculated t value as 1.04. Now we need to find the table value at 5% level of significance, and the degrees of freedom is n1 plus n2 minus 2. So it is 10 plus 17 minus 2, which is 25. So at 5%, so we have to check the area in 2 times 5% and 25 degrees of freedom. So the value is 2.06. Therefore, the critical t value is 2.06. Now we have the step 3. At 5%, at alpha equal to 5%, at alpha equal to 5%, critical t value for 25 degrees of freedom, it is equal to, we got 2.06, equal to 2.06. We got the calculated value as 1.04. Therefore, calculated mod t is less than critical t value. Critical t value is nothing but the t value that we got from the table. So, as a result, we can accept H naught. It means the fourth step is the null hypothesis accepted at 5% level of significance. Hence, there is no significant difference between the mean life of the two batches of electric bulbs. That is, mu1 is equal to mu2. So, we have the result. Next question, strength test carried out on samples of 2 yarns spun to the same count gave the following results. Here we have the sample yarn A and yarn B. Sample mean is 4 for yarn A and 9 for yarn B. Sample size is 50 and 42. Sample variance 42 and 56 respectively. And now the strengths are expressed in kg Is the difference in mean strength significant of real difference in the mean strength of the sources from which the samples are drawn? So here everything is given directly, and it is asked, is a difference in mean strength significant of real difference in the mean strengths of sources from which the samples are drawn. So here we have to check whether the population mean, the mean strengths of the sources, that is the population mean, whether there is any significant difference between those sources. So we have the first step is null hypothesis H0. There is no significant difference between the mean strengths of the sources from which the samples were drawn. That is mu1 equal to mu2. And the alternate hypothesis is there is significant difference between the mean strengths, which means mu1 not equal to mu2. Now the test statistic is given by t is equal to x1 bar minus x2 bar upon sp into root of 1 by n1 plus 1 by n2, or it is equal to x1 bar minus x2 bar upon sp into root of n1 n2 by n1 plus n2. So we have n1 equal to 50, n2 equal to 42. So this is the sample size. And then x1 bar equal to 4. It is given here. x2 bar is 9. x2 bar is 9. And then the sample variance is given. S1 square is given directly. It is 42. And S2 square, it is 56. So everything is given here. Now let us find SP. SP is equal to root of n1 S1 square plus n2 S2 square upon n1 plus n2 minus 2. So this is equal to root of 50 into 42 plus 9 into 56 upon 50 plus, this is plus 42 into 56. So 50 plus 42 minus 2. So this is equal to root of 2100 plus 2352 upon 90. So it is equal to 4452 upon 90, or when we simplify and take root, we get this as 7.03. Now let us find t. T is equal to x1 bar minus x2 bar, so 4 minus 9. 4 minus 9 upon 7.03 into root of n1 n2 upon n1 plus n2. So this is equal to minus 5 by 7.03 into root of 2100 upon 92. So this, when we simplify, we get it as 4.78. So finally we get t value as minus 3.4. So from this we have mod t is equal to 3.4. Again here, since the level of significance is not given, so let us take alpha equal to 5%. And the degrees of freedom will be n1 plus n2 minus 2. So it is 90. So here we have the table value. So for degrees of freedom 90 and 5% level of significance, The critical t-value is 1.987. 1.987. So we have it here. So we can write the next step. The next step is at 5% level of significance, the critical t-value with 90 degrees of freedom, it is equal to 1.987. Since mod t greater than the critical t-value, we have to reject H0. So we have found that the calculated t-value is greater than the critical t-value. The null hypothesis is rejected at 5% level of significance. Hence, there is significant difference between the mean strengths of the sources from which the samples are drawn. So we have the result here. Next question, samples of two types of electric bulbs were tested for length of life and the following data were obtained. So here they have given the number of bulbs, mean and standard deviation. Is the difference in the sample means significant? Given T13 at 5% level of significance is 2.16. So first we have the null hypothesis. There is no significant difference between the means, and then the alternate hypothesis H1, there is significant difference between the mean. Then the next step is the test statistic. It is given by x1 bar minus x2 bar upon sp into root of 1 by n1 plus 1 by n2, or it is equal to x1 bar minus x2 bar upon sp into root of n1 n2 upon n1 plus n2. So we have everything given here. Let us write so that it will be easy for us to solve. We have n1 n2, x1 bar x2 bar, and the standard deviation s1 and s2. n1 is 8, n2 is 7 given here, and the mean is 1134 for type 1 and 1024 for type 2. And then we have the sample standard deviation 35 and 40. Now let us find the variance. So sp equal to root of n1 s1 square plus n2 s2 square upon n1 plus n2 minus 2. So it is equal to root of 8 into s1 square is 35 square plus n2 is 7 into s2 square is 40 square upon 8 plus 7 minus 2. So this is equal to root of this. When we simplify, we get 9800 plus 11200 upon 13. So it is equal to root of 21,000 upon 13. This when we simplify, we get 40.2. Now let us find T. So T we have x1 bar is 1134, x2 bar is 1024, upon SP we have 40.2 into root of n1 n2 by n1 plus n2, n1 is 8 and n2 is 7. So 1134 minus 1024 upon 40.2 into root of 8 into 7 upon 8 plus 7. So this is equal to 110 upon 40.2 into this 56 upon 15. So it is equal to root of 3.73. So this is equal to root 3.73 is approximately 1.93. This when we simplify we get 5.28. 5.28. Now this 5.28 is more than the critical t value at 5% level of significance and 13 degrees of freedom. Therefore, we have to reject H naught, and hence there is significant difference between the means. So 5.28 greater than 2.16. So we have the next step, step 3. The calculated mod t greater than critical t value, which means the null hypothesis is rejected at 5% level of significance. Hence, there is difference between the means. Next question, two methods of performing a certain operation are compared. The following data are obtained. So, n1, n2, x1 bar, x2 bar, s1 square, s2 square, all these are given. Is there a significant difference in the means of the two methods at 5% level of significance? Given the critical t value for 5% level of significance and 25 degrees of freedom is 2.06. So, here we have to test whether there is any significant difference in the means of these two methods. Here we have the sample mean and the sample variance which are given. So first step is null hypothesis and the alternate hypothesis. Null hypothesis H naught is there is no significant difference between the means, and alternate hypothesis H1 is there is significant difference between the means. Now the test statistic is given by t equal to x1 bar minus x2 bar upon sp into root of 1 by n1 plus 1 by n2. So it is equal to x1 bar minus s2 bar upon sp into root of n1 n2 upon n1 plus n2. Since everything is given in the notation that is required, I am not rewriting it here. Now let us find the pooled standard deviation. Sp equal to root of n1 s1 square plus n2 s2 square upon n1 plus n2 minus 2. So Sp is equal to root of n1 is 15 and s1 square is 9.5. So 15 into 9.5 plus 12 into 5.7. n2 is 12 and s2 square is 5.7 upon n1 plus n2 minus 2. So this is equal to root of 142.5 plus 68.4 upon 27 minus 2, 25. So this is equal to root of 210.9 upon 25, or it is root of 210.9 is approximately 14.52 upon 5. This is approximately equal to 2.9. Now let us find t. So t we have x1 bar minus x2 bar. x1 bar is 50.5, x2 bar is 57.2. So 50.5 minus 57.2 upon, here we have SP is 2.9. So 2.9 into root of 15 into 12 upon 15 plus 12. So this is equal to minus 6.7 upon 2.9 into root of 180 upon 27. So it is equal to this, when we simplify we get 6.67. So it is equal to minus 6.7 upon 2.9 into 2.58. This when we simplify we get it as 5.9. Negative 5.196. So mod t will be 5.96. So here we can see that the critical t value at 5% level of significance with 25 degrees of freedom is 2.06. So 5.96 more than this 2.06. As a result, we have to reject H naught. It means there is significant difference between the means. So step 3 is mod t greater than critical t value. So we have step 4, the null hypothesis is rejected at 5% level of significance, and step 5, hence there is significant difference between the mean of the two methods of performing certain operation. Moving on to the next question. The means of random samples of sizes 9 and 7 are 196.42 and 198.42 respectively. The sum of the squares of deviation from the respective means are 26.94 and 18.74 respectively. Can the samples be considered to have been drawn from the same normal population? So here the sample sizes are given, the sample means are given, and sum of the squares of deviation from the respective means are given. We need to test whether the samples are drawn from the same normal population, that is, the sample means are equal. So the null hypothesis is there is no significant difference between the means, and the alternate hypothesis H1 is there is significant difference between the means. Now here for writing the test statistic, we need to find the pooled variance. So it is given by root of n1 s1 square plus n2 s2 square upon n1 plus n2 minus 2. Now this s1 square, it is nothing but it is 1 by n1 into summation x1I minus x1 bar the whole square. Similarly for s2 also. So we have sp equal to root of n1 into 1 by n1 summation x1I minus x1 bar the whole square plus n2 into 1 by n1 into summation x2I minus x2 bar the whole square. So this n2 and n2 will go, this n1 and n1 will go. The whole thing upon n1 plus n2 minus 2. So we have sp is equal to root of summation x1I minus x bar the whole square plus summation x2I minus x2 bar the whole square upon n1 plus n2 minus 2. So we can use this formula because the sum of squares of deviations from the respective means, these values are given. So to find sp, we can use this formula. So here, since the sum of squares of deviations from the respective means are given, we can use the formula for sp that I mentioned just now. So the test statistic t is given by t is equal to x1 bar minus x2 bar upon sp into root of 1 by n1 plus 1 by n2. This is equal to x1 bar minus x2 bar upon sp into root of n1 n2 upon n1 plus n2. Now let us write what are all is given. We have n1 equal to 9, n2 equal to 7, x1 bar is equal to 196.42, x2 bar is equal to 198.42. Then summation x1I minus x1 bar, this is equal to the whole square, this is equal to 26.94. Then summation x2I minus x2 bar the whole square, this is equal to 18.74. So all these values are given. Now let us find SP. SP is equal to root of summation x1i minus x1 bar the whole square plus summation x2i minus x2 bar the whole square upon n1 plus n2 minus 2. So this is equal to root of 26.94. So this is what is given here. The sum of squares of deviations from the respective means are 26.94 and 18.74 plus 18.74 upon n1 is 9, n2 is 7 minus 2. So this is equal to root of 45.68 upon 14. So it is root of 3.26 is approximately equal to 1.8. Now let us find T. So T is equal to x1 bar is 196.42, x2 bar is 198.42 upon SP is 1.8 into root of n1 n2, 9 into 7 upon 9 plus 7. So this is equal to minus 2 by 1.8 into root of 63 upon 4. Since 9 plus 7 is 16, root 16 is 4. So this is equal to minus 7.94 upon 1.8. Now this, if we simplify, we get it as negative 2.2. So from this we have mod t equal to, it is equal to 2.2. Now we have to check whether we have to accept or reject the null hypothesis. Here the degrees of freedom is given by n1 plus n2 minus 2. So n1 is 9, n2 is 7 minus 2. This is equal to 14. So at 5% level of significance and 14 degrees of freedom, we have to see the table value and check whether the calculated t value 2.2 is less than or more than the tabulated value. So let us take at 5% level of significance and 14 degrees of freedom. The t value is 2.145. So the critical t value is 2.145. Now we have the next step. Step 3, at 5% level of significance, with 14 degrees of freedom, critical t value is equal to 2.145. Therefore, the calculated t value is more than the critical t value. So as a result, we have to reject H0. So the null hypothesis is rejected at 5% level of significance, which means there is significant difference between the means. So we cannot consider the samples to be drawn from the same normal population because we have got the result as there is significant difference between the means. I hope this video was useful for you. Thank you for watching.